Bam! Hello, everyone. We're continuing with our series on coding practice streams. Today we have the lovely faeries-vods. We figured out how to do stuff. Oh God. I just get distracted when I'm streaming. Show me the chat. There's the chat. But no, so it turns out, so we use Vroid to make our VTuber avatars, right? And faeries-vods has a Vroid model, which, there she is. I always forget. Because Vroid, Unity, they all use slightly different, like, short controls. Like, VC Face is based on Unity, but, like, it doesn't. Different buttons in BC phase. Oh no! Don't shake the puppy! Don't shake the puppy. Then it is on Vroid. And anyways, but we figure out they have this website because Pixiv owns Vroid, and they have like a website, and you can upload your models to the website, and then you can like get animations. This is a little bonus for those of you who are here early. You get to, before we start working. Tail shop post set. Foodie. Okay, but can you give me shit that's free? Toothless dance. I don't know what's going on here. Internet, Yamero. Mic free posts. Some of these are horny. Bing bang, bling bang bang born. Mermaid. Whoa. It's in .anim file. Oh, there's a VRMA. Ah, beautiful. Okay. Just AC. Select. YouTube. And it's pretty cute. It's pretty cute. Look at that, it's a whole routine. Oh, my finger went in it. Let's take a little clip of that, why don't we? It's pretty cute. It's pretty cute. Okay, let's get back to our radically scheduled duties with. Uh-oh, I forgot the clip is playing. Let's dive in. Let's keep tackling some sets. All right. In today's lesson, we'll dive into the world of Python sets. We'll focus on leveraging this powerful data structure to solve two common interview problems. Set's ability to handle unique elements can simplify and optimize our problem-solving process, making it more efficient. So if you're ready to discover the powers and nuances of using sets to solve problems, let's get started. I'll probably go faster without Cosmo the space dog, but you know what they say, if you want to go fast, go alone. If you want to go together, if you want to go far, go together. Jesus. Our first problem involves identifying the first unique string from a list. Imagine you're working on a text analyzing tool that needs to identify the first unique word in a piece of text. The problem simulates such a real-world scenario. Hey, you don't need to tell me the naive approach every time. Defining property of a set is that it contains unique elements. Our strategy consists of two parts. We scan through the words, keeping track of the previously encountered words in a set called seen. A crucial aspect of our solution comes from an inherent feature of set. If a word is already seen, adding it again does not change the set. Keeping this in mind, we create a second set duplicate, consisting only of words we have previously seen. Once we know which words are duplicates, it becomes elementary to find the first word in our original list that isn't a duplicate. We make another pass over the list, checking each word to see if it's in the duplicate set. The first word we find that isn't in duplicates is our answer. This is taking two strings and finding the single element is different. Two single pass traversals, giving our solution a linear time complexity of O to n. A significant improvement over the naive approach. Oh, so it does know how to use constants. Okay. For words in words, if words in seen, duplicates. See, and this one's nice because it does it without an else statement. So before, when I was doing tests and I would do this. Well, here I did it without a set. Well, sometimes I was writing if else's instead of just ifs, and I prefer doing just ifs when I can. Alright, the window with Cosmo, the space dog. This could create two sets. Seen contains all words we've come across, and duplicates contain words that have appeared more than once. In the next phase of our solution, we iterate over words again, checking if a word is in duplicates. The first word that is not in duplicates is our answer. It is the first unique string in the list. If we don't find any unique string, we return an empty list. Okay. Identify all pairs of anagrams for each pair. I feel like I wonder if they could just let me do the exercises. Because I kind of wish they would just let me do the exercises. Oh, here we go. Hold on. Fine, I'll read the thing. There's cryptography. Cryptology? I guess they're technically the same thing. All pairs of anagrams where each pair is made up of one word from the first list and one word from the second list. Consider a cryptology scenario. You've intercepted two separate messages, each consisting of a list of coded words. You suspect that there might be some connection between the two messages. Specifically, that some words from one list are anagrams of words in the other list. Your goal is to find these pair of anagram words to decipher the code. The most straightforward approach to this problem would involve checking each word. No, forget. I don't need to read this. We can achieve a more efficient solution by representing each word from both lists as a sorted tuple of characters. So you're taking each word and turning it into... So is a tuple like a set, but with duplicates? And two words are anagrams. Once we have these sorted tuples, we can use Python set methods to find pairs of words that are added to each other. Oh gosh! Oh, got hit by an attack of the sleep here. Good thing I have coffee with me. So let me think about how I would do it, right? So you decompose words into these tuples of their letters, just a string that has their letters organized from beginning to end. I don't really understand why they need to be tuples. But I'm sure it'll tell me. But the idea then is like, boom, you have all words then would have like a value. It's almost like a hash where two words that are anagrams will have the same value. Now those sets themselves have unique character tuples. We find the common tuples between the two, which represent the anagram word. And this is interesting because by using a set, when there are words in the same set that are anagrams of each other, that information is destroyed because we're only storing in the set one instance of this hash, this tuple, this string. If its sorted character tuple is present in common tuple set, we add it to the respective output list. So it's making the set of the tuple of the sorted word for word in list 1. And then it says you add... Oh, I forgot about the AND operation last time when I was trying to do a thing. And it let me just not do it. What was the thing I was trying to do that I could have done with an AND, probably? Huh. Could I have done this? I do have two sets. But just adding a set? Should it work? Alright. 10, 9, 8, 7, 6, 5, -1, -2, -3, -4, -5. Yeah, so see, even though I learned this, when it was time to use it, I had forgotten it. So I guess there's some value to going over it again, even if it seems boring, because you need shit to cement in your brain. I need cement in my brain. Finally, we return a list of tuples, where each tuple is an anagram pair from list 1 outputs and list 2 output. O n plus m times O of n plus m times log of n plus m plus p, where the size of list 1 and p is the number of word pairs in list 1 output and list 2 output list, which makes the solution much quicker and more scalable than the naive approach. Note that as not every pair in list 1 output and list 2 output is actually an anagram pair, time complexity of the solution can potentially degrade to quadratic places in rare cases while still having not too many anagram pairs in the output. So for word 1 in list 1, so we assemble these outputs, which is composed of word for word in list 1, a tuple sorted word in common tuples. And this adds every word that this is a list. So it adds every word. There shouldn't be duplicate words, but even if there were, it would add them. And it definitely adds words to the list, even if they're different representations. Solution, all right. So it makes these lists that have each word that we know will have an anagram in the other word, but then we still have to go through the entire list. We still need to do this loop that is n squared. Well, log of n plus m. And p is the number of word pairs in list. Well, but these aren't the original. Yeah. It's not n plus m squared because p, list 1 output and list 2 output are going to be shorter than the original 2 lists, but it's still going to be pretty long. Here's a way to do it with dictionaries, which I'm excited about because I like dictionaries. But you know what I am mad about? And maybe I'm gonna go away and go study this because they haven't explained to me the internals of a hash or a set. Haven't explained to me why these operations are so quick. So we might dive into that in a second. So we make a dict of list 1. Here's how this works. For word in list 1, sorted tuple equals let me see something. Touch dict. Practice. Pi. Oh, Apple, race car, giraffe. Oh my god, dude, you're so annoying. You are. Windows. Ooh. Huh. That is worse. You get how that is worse? Ack. Alright, so what's an anagram of apple? Should have just gotten some anagram pairs of the internet. Here you go. This is the wrong VS Code. Okay, so I need care, race, race part hard knee.
I won't give up on you. Come with me. Be free.
I think I can fix the thing with the quotes, but one thing at a time. Care, trap, earth, and so what I would like to know is what does default dict do? What does the default dict do? Right. This is just making an empty dict that's going to contain lists. The mapping of the sorted tuple dot append word. Right. I get it, 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 I get it. So you wanna use default dict list so that it populates the entire dictionary, or like it is ready to accept a list. So with this, we're able to say for every item in list 1, the key is going to be the tuple. The key is going to be the string that, like for instance, I can tell you, for word in list 1, print sorted tuple sorted open, open, close, close. What doesn't it work? What did I miss? Oh, 3 print. So And because they're tuples, they're like this. Acer, Aper, card. And so if we do the same thing, but with list 2, they should look exactly the same because of the way we composed our list. And this will store, we'll take a dictionary where the key is this bullshit. I still don't understand why they need to be tuples. I feel like you could have done it with string. From mapping 1 and mapping 2 to get common sorted tuples. Every element. So now you're making a set of just the keys to make the common tuples. It's the same thing as before. For anagram tuple in common tuples. For word 1 in mapping 1. Anagram tuple. So this will get this will take whoa. Each one of these, Jesus, each one of these will just have 2, right? For word 1. Yeah, and this, because this will also make pairs. This will also make pairs of ones where it's like, okay, this list, like, okay, say this list also has so if we do it normally, right? It gives you trap part, care, race, earth, heart, king, knee. But if I say I added the word tarp to the second word, it would need to do trap part, trap tarp, care, race, earth, heart, king, knee. It still doesn't answer where you need a tuple. You need tuples after when you're returning them, and we do return them as tuples. If I ask Cosmo, he won't say anything. Could ask Claw, but I don't wanna. Matter of fact, look what happens if I just get rid of the tuple and I just use words. And once they're added, I want you to print this each time. Unhashable type list. Because a list, because it tries to do it as a list. Like, you could do it as a string, but you have to do stir. You can't just rely on it. But I think this should work. Yeah. It's still... Well, it did work, but it's still returning them as lists instead of strings. Oh, why did it work this time? Why are you a string? Why are you a list and not a string? Made no difference. Because sorted returns a list. Lemao. Fucking mao. It's just a list. This using the string method on a list returns a string with the brackets. At least if you print it. I didn't even print it. That's not me printing it. That's just me saying it. If I use print, then it doesn't have the quotes because it's just a string. That's fucked up, dude. Anyways, it's a cute solution. I like it. And I learned a little bit about dictionaries. I should be... making notes of all the things that I'm learning. Alright. 30 more minutes. What can we do? Right. Right. Share on LinkedIn. I don't think I can sign into LinkedIn anymore. Let's not worry about this. Arrays and strings. I haven't used a single array. Apple, banana, apple, mango, banana. Hello world, hello, hello world, hello, hello. So the last unique string. But if there are multiple unique fruits, either way, you do for word in words, do seen equals set duplicates equals set for words in words if word in scene duplicates dot add word dot add word. Doesn't that mean that? Huh. That's funny. This isn't actually equivalent. This runs the instruction to add word to scene every time. It doesn't do a logic check. It doesn't do else. It just does it. It just doesn't matter because if it's already being added, it won't do anything. But I don't like it. I don't like it. It's really just throwing an else in there. Like else, does else need to do any logic? Like, is there any world in which this is more expensive? I don't think so. If the if executed, the else is just skip. So I'm gonna stick to my else's for now. And then what you want to do is it says return the last word that's not a duplicate. So except it only return one word, so it should return scene minus duplicates. What happens if I just have it do that? But then it returns sets. If I have it to stir, well, that's a dumb way to do it. No, what you need to do is wait, does that work? Not subscribable. Can you pop a set? Pop from an empty set. this case you can, because it'll just return in these cases, otherwise it'll pop. Resolution doesn't guarantee finding the last using string. It's finding any it takes. But what do you mean? Mango is what you wanted. It should print mango. But by popping, is it because am I not? Is popping? Am I supposed to pop from the other side? I thought popping guaranteed. Those implies that an order collection removes an arbitrary element. Considering using a list to keep tracks of the unique words in the order to they appear. So, interesting. This requires me creating the whole set, but actually, instead of using a list to keep track of the unique words in the order they appear. The last unique string on the list. Apple, banana. So, like, let's think about if I was going through this. Apple, okay, it goes in scene. Banana, okay, it goes in scene. Apple, okay, it goes in duplicates. Mango, okay, it goes in scene. Banana, okay, it goes in duplicates. But sets are unordered collections. So, but at this point, even though I've identified a duplicate, I don't actually know what the unique words are. So, like, I can say that the best I can do is okay. Jesus Christ. For I in range. Len word to 0. This work. To 0 in steps of -1 if words of sub I in unique words return. This is the worst thing. Now I have to. Well, no, this will go through the whole list. And ideally, you only need to go through the list of unique words. But you only need to go through the list of unique words. You only need to go through the list of unique words. You only need to go to the list of unique words. But you have to find out where it is on the list. I mean, this is a way to do it. Banana, world, none. Okay, how do you do the empty set? Right, that's an elementary mistake. It's so ugly. I'm bringing in a ringer. word is unique words does remove word. Else you return unique words -1 if unique words. We iterate through each word in words. If the word is not in the repeated, if the word is already unique words list, means previously considered unique, but now it's a repeated word. We remove it from unique words and iterate. Processing all the words, if there are any unique words. It maintains the order of unique words and efficiently updates the list set as and count. Then completes the solution so found where n is the number of words in the list as we iterate through the list once. How cheap is the remove operation though? How does Python handle word list? Does it not have to go through the list? Right? In the worst case, where all the words in the list are unique, except for the last word, which is a duplicate of the first word, we would need to perform the remove the word operations. This will result in a quadratic time complexity. To avoid this inefficiency, we can modify the solution to use a dictionary instead of a list to store the unique words along with their last occurrence index. Here's an optimized version. Unique words from repeated words equals set. For I words in enumerate words, oh boy, now we're using enumerate. If word not in repeated words, if words in unique words, del unique words words, repeated words that add words, else unique words word I. If unique words return words max unique words values. To store the unique words as keys and their last occurrence indices as values. We also initialize an empty set called repeated words to keep track of the words that have been repeated. We iterate through each word in the words list along with its index using enumerate. So enumerate just gives you indexes. Doi. If the word is not in the repeated word set, it means it hasn't been repeated yet. If the word is already in the unique words dictionary, it means it was previously considered unique, but now it's a repeated word. We remove it from unique words using del and add it to repeated words. If the words is not in unique words, we add it to the dictionary. After processing all the words, if there are any unique words in unique words, we find the maximum index value. Damn. Max unique words or value, or return the corresponding. So words is the dictionary? Words is just. Yeah, because we need the value. We need the value. The value will have the highest possible word. Yeah. In this operation, solution, the del operation in a dictionary has an average case time complexity. Cool. Not really gonna let me do it again though, but that's fine. Cinema into Iceman. They can be of any size and words may repeat. As for the output, we need a list of unique words from the first list that have anagrams in the second one. Alright, let's do this. So it's funny because we only need the anagrams for the second one. So what we're gonna do is we're gonna make our list, our deck of anagrams, list to it's gonna be, let's just fucking do it with the tuples for the word forwarding list 2. Hi Jams, thank you for the pets. We love getting pets. We're solving this problem, this coding problem with dictionaries and anagrams and the Iceman. The Iceman cometh. I always get the Iceman confused with Waiting for Godot, but they're different plays. So this will get us the tuples for the second one, and we just need to find unique words from the first array that can rearrange the letters to match at least one word in the second array. So now we can go forward in list 1. If tuple sorted word watch out for case sensitivity and one letter words. Okay, well, let's just make sure that we're always comparing uppercases. So if any of the words in list 1 have a tuple representation that matches the anagrams in list 2, I'm going to make a unique words list. Unique anagrams. Oh, look at me. I'm just gonna do it like this. It's gonna increase my time complexity a bit, but I think it should be okay. actually shouldn't be a problem. Does Python sets have a remove operation? Sure. I'm gonna assume it's okay if they're not in the same order. So, okay, unique anagrams list. And then we could do a unique anagrams, and it could be a set. And we need a scene. You don't need a scene set. So, okay. If word in unique anagrams unique anagrams dot remove. But then if it shows up again, so we should probably just do unique anagrams list equals set. It's a list, and then we do scene words equals set. If word in, so if it finds a word that has an anagram, it should add it. If the word is in scene, it's like every time, so we should add the word to, so we find it, we go through the list, and so once it hits an anagram, it should add it to the list of anagrams. But then if that word shows up again, it should remove it. So actually, like, what we would do is we see the word the first time and we add it to the unique anagrams list. And then immediately, if word in scene words, you remove it from unique anagrams list. This is gonna do this for every anagram. Well, but let's assume that we're not working with the worst case scenario where there's tons of duplicates. And then it would only have to do, but it'll do it again, right? Because if the word is in, so if it's in scene words, doesn't matter. The first time, it'll just collect all the anagrams, but each time it'll check if it already had it and remove it, and if it didn't already have it, but if it didn't already have it, it'll get to stay. So this should work. And only then do you add the word to scene words. So the first time it will be okay only if it runs again and it finds that word again, and then it gets stricken from the list. And then even if it is found again, it won't get added. It might get added to the list again, but it'll also be removed immediately every single subsequent time, because it doesn't get removed from seen words, it just gets removed from the unique anagrams list. And so then finally you return the unique. Hello? Must have messed something up at some point. There we go. Try it. To return cinema, Iceman. Right. Because they're different words. They're anagrams of each other, but that doesn't actually matter. What matters is that they have anagrams in the other list. Let's see. Nice. Cool. And that's... Oh, see, okay. Hash tables, implementation and complexity analysis in Python. This is the thing I was complaining about not having covered yet. So I might not want to dive into it today since it's already been an hour and we're doing... Yay, thank you! The fairies have won 3 times. And we're doing these only for an hour? Well, let me see. The lighting structure and mechanics of hash tables, how they handle conflicts and collisions when multiple keys hash the same index, and how to perform complexity analysis to understand their efficiency. Okay. Cool. Was this near music? It's Super Castlevania. Every time a song sounds like this, I'm like, is this near? I should just play near. Oh my god. Okay. So with that in mind, we'll be back tomorrow, and then tomorrow we'll be back tomorrow at 2, and then tomorrow we'll just play Minecraft. So if people want to come play Minecraft, just check out exclamation mark Minecraft to get the server address. Just pop by during the stream and ask me to add your character to the server whitelist, and then you can play Minecraft in the server with all of us. I'll also be making sure that the server is running. Please let me know if you're enjoying the coding practice streams. I think we're gonna do them. We're gonna keep doing them for a bit because they're good. Because you know, 3 days now this week, I managed to sub. Hi Ray. Thanks for stopping by. I was just saying that, yeah, it's been good that now Tuesday, Wednesday, and Thursday we've managed to do coding practice. The plan was to not do coding practice tomorrow and just go straight to the Minecraft. But then either next Monday or next Tuesday, before we do something else on stream, we'll do some more practice. And I'm thinking about like ways that I can like change up this, or like I would like to solidify this into a schedule. I think it might be cool to stream 4 to 5 days a week and just have a lot of those streams be short and sweet, you know? But I just want you all to know that I do value community feedback, and that I'm doing this for myself because I want to get better at coding. But I'm also trying to provide like something that's interesting and engaging, and that maybe helps other people who are also trying to become better coders, to see me work through these things, and to understand these concepts better. Not exactly teaching, I'm learning, but we're trying to learn together. Yay, we're glad you like it, James. Also reminders, so here's some reminders. Here's the Minecraft server, here's the Discord server. The Discord, you can also talk to people about this, anything code, Minecraft, anything you want. The Discord's still pretty new, so like if there's a channel that we're missing, we can add it. It's like still growing. If you've been enjoying the stream, remember to like and subscribe. You don't have to subscribe, but it'd be nice, we do appreciate and love all our subscribers. But you can like the stream by liking it, and you can follow the stream. That's the word I was missing. You can follow the stream by clicking on the little heart. So thank you so much. I am gonna raid someone. I'm trying to see who's a cool person streaming. There's someone doing art. That's cute. There's this person I met the other day and they're playing Animal Crossing. That's also cute. Let's do that. She's doing a subathon too. Let's hit her up. Thank you so much for watching, and I will see you all tomorrow for some Minecraft. I'm gonna say find out how I can do this. Ciao!